Hey there, Algebra 2 students. Today we need to talk about permutations and combinations. So we will go over a few vocabulary terms to start. So what is a permutation? A permutation is an arrangement of objects in which order is important. Okay. N factorial. Notice it is written as n exclamation point. We don't say that is n. All right, it's n factorial. It's the product of the integers from 1 to n. So like n factorial is n times n minus 1 times n minus 2 dot 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 times 3 times 2 times 1. And we'll do some examples with that later. And a combination is a selection of objects in which order is not important. Okay, so then let's come down here to our core concepts. We are on page 305 of your student journal. Permutations. Okay, the number of permutations of n objects is given by npn, where it's n factorial, right? And so this is the number of permutations of 4 objects is essentially 4 factorial. 4 times 3 times 2 times 1, which is 24. And the number of permutations of n objects taken r at a time, where r is less than n, is given by npr, right? The number of permutations of taken r at a time. So you got n factorial divided by n minus r factorial. And they give an example briefly of the number of permutations of 4 objects taken 2 at a time is 4p2. So 4 factorial over 4 minus 2 factorial, which is 4 times 3 times 2 times 1, or 2 factorial, over 2 factorial. And the 2 factorials can cancel, right? And you're left with 4 times 3, which is 12. Okay, so that's the basics of permutations. Let's look at some basics of combinations and we'll do some example problems. So for a combination, the number of combinations of n objects taken r at a time, where r is less than or equal to n, is given by the formula NCR, which is n factorial over n minus r factorial times r factorial. And the number of combinations of 4 objects taken 2 at a time, so 4 choose 2, will be 4 factorial over 4 minus 2 factorial times 2 factorial. So you'd have 4 times 3 times 2 factorial over 2 factorial times 2 factorial, which is 2 times 1. The 2 factorials can cancel, and 2 also divides into 4, so you end up with 6. Okay. Before we do some example problems, I want to show you real quick on your handy dandy Casio calculators. Handy dandy calculators. Okay. There, if you press the OPTN button, you got list, mat, which is short for matrix, right? Complex, calculus, stats. We're going to press the arrow button. You see prob. Probably going to need this prob button for probability. And you can see x factorial, NPR, NCR. For these two, you need to enter a number before and after to evaluate. And then you would press enter. And we'll show you how to do that in a little bit. But I wanted to show you where it was. So again, you press the OPTN button, the arrow button to get prob. So prob, and that brings you your probability functions. Okay. So let's look at some of these extra practice problems, right? In exercises 1 and 2, find the number of ways you can arrange A, all of the numbers, and B, 3 of the numbers in the given amount. So the important thing is counting the number of digits, right? And so in question 1, there are 7 digits. And so if we're just arranging them any which way, that would be 7 factorial. And I can show you on your calculator. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Or with our calculator, we could do 7 and then the factorial button equals 5,040. Boom. Okay, well, what about this? 7p3, right? 7, you've got 7 numbers that you're working with, and you want to choose 3 of them. But the order is important, right? Order is important, and so we're going to use a permutation instead of a combination. And so we would do 7 factorial over 7 minus 3 factorial. And if we're doing this by hand, you know, it's 7 times 6 times 5 times 4 factorial over 4 factorial, and the 4 factorials cancel because they're both 4 times 3 times 2 times 1. So all of the things just cancel. And you're left with 7 times 6 times 5, which is 210. Now, I just want to show you on the calculator how to do that. So this was 7p3. So I would type in 7 and then the NPR button, and then I would type 3 and execute. And you get 210. Bueno. Okay. Let's look at number 3. Your rock band has 9 songs recorded, but you only want to put 5 of them on your demo CD to hand it out to local radio stations. Duh. How many possible ways could the 5 songs be ordered on your demo CD? So order is important. So we're going to use permutation. So it'd be 9p5. And you could enter this into your calculator, or you can use the formula here. 9 factorial over 9 minus 5 factorial. 9 minus 5 is 4. So we would do 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. The 4 factorials cancel. You do this multiplication and you get 15,120. Okay. We'll do a couple more examples here. I don't want this video to be too long. But a witness at the scene of a hit-and-run accident saw that a car that caused the accident had a license plate with only the letters IRLTONA. I don't know how they memorized all those letters, but they did. So find the probability that the license plate starts with a T and ends with an R. Okay, well, you need to find the total possibilities, the total number of permutations. So if you had those 6 letters and they could be anywhere, right? It would be 6 factorial or 720 possibilities. And if those 2 are in place, then there are only 24 options, right? Or 4 factorial options. And so you do 24 over 720 and you get 1/30 for your probability there. Okay, for 5, how many possible combinations is a keyword, of 3 colors can be chosen from the 7 colors of the rainbow? So you've got 7, choose 3. How many combinations? So we would use the formula 7 factorial over 7 minus 3 factorial times 3 factorial. The 7 minus 3 is 4 factorial. So I did 7 times 6 times 5 times 4 factorial over 4 factorial times 3 times 2 times 1. The 4 factorials cancel. 3 times 2 is the same as 6, so that would cancel. then you'd be left with 7 times 5, which is 35. 35. And then number 6 says use the binomial theorem to write the binomial expansion of 2x to the 4th plus y cubed. And I did this down here using the formula on the opposite page and working very carefully, right? So this is 3 choose 0, which is 1, times the first term, 2x to the 4th, raised to the 3rd power, times the second term, y cubed to the 0 power. And this term will be in descending powers, right? So 3, 2, 1, 0. Whereas the second term will be ascending, so we've got 0 power, 1 power, second power, third power. And in front we have multiplied by 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, which end up being 1, 3, 3, and 1, respectively. And so, yes, then we simplify, right? So 2 cubed is 8, x to the 4th to the 3rd is 12, y cubed to the 0 is 1. 3 choose 1 is 3. 2x to the 4th, when that is all squared, that would be 4x to the 8th. Y cubed to the first power is just y cubed. 3 choose 2 is 3. 2x to the 4th to the first power is just 2x to the 4th. Y cubed squared is y to the 6th, right? 3 choose 3 is 1. 2x to the 4th, all of that raised to the 0 power is also 1. And y cubed is y to the 9th power. And so when we simplify all of that in that last step, we get 8x to the 12th plus 12x to the 8th, y cubed, plus 6x to the 4th, y to the 6th, plus y to the 9th. And that is how you do lesson 10.5. I hope you're well. We'll see you next time.